So hello friends, we will start new chapter number 1 of NCERT Mathematics, rational number. You can see rational number. First of all, we will start with the mind map, which you can see here. We will try to understand this Venn diagram. What exactly is this? You can see here natural numbers, and there is a whole number, integers, and rational number. Rational numbers is having a bigger circle out of these all number series. Now the main motive of this Venn diagram is rational numbers is actually containing the all series, integers, whole numbers, and natural numbers. You know that natural numbers starts with 1, whole numbers start with 0, and integers are whole numbers including negative whole numbers. Negative inverse of whole numbers, you can say that. So, and what is the rational number? Rational numbers are all the series, all the numbers, natural numbers, whole numbers, integers, all are called rational numbers. Now, this is the main motive of this Venn diagram. You can draw in your notebook. Now, next is meaning of rational number. What do you mean by a rational number? So first of all, we will just try to understand a number that can be expressed as a ratio between two integers. Why I am taking integer? Because integer is a big term than whole numbers and natural numbers, and they are called rational numbers. For example, suppose I am taking in terms of a and b. Let a and b, a upon b is a rational number where a and b are any integers where b cannot be equal to 0. This is very important to understand this condition. For example, 3 upon 4, 4 upon 5, 2 and 3, and all the numbers which you have studied in the previous classes. The main question comes in the mind, why b is not 0? What is the reason behind it? If denominator is 0, then the value of rational number will be undefined. Why? Because if any number is divided by 0, you can see here 3 divided by 0, and it gives you undefined always. This is very important. Generally students do the mistakes here. Now next term is equivalent rational number. Equivalent integers, equivalent whole numbers, equivalent terms, very well. What do you mean by equivalent? Equivalent means here 1 upon 2, 2 upon 4, 3 upon 6 represents same rational number, because ultimately when we simplify all the three rational numbers, they will reach to the same value, right? So that's why they are called equivalent rational numbers. And I just want to tell you one thing also. Rational numbers and integers, somewhere they are correlated to each other in so many properties, right? Why they are different with the integers and the other things? Because integers are a complete number. They don't have the denominator except 1. There is only single denominator, always unique denominator here, that is 1. But in rational numbers, denominators will change, due to which we are getting a new number series, right? So now next point is positive and negative rational number. Positive, and there is a lot of confusion in the student's mind. A upon b, minus a upon minus b, they both are positive. Mostly students know this. Minus a upon b and a upon minus b, both are negative, because negative should be at one place, either in numerator or in denominator. This is the basic fundamentals. And after this, you can see I have written one thing here, important points. All the rational numbers are terminating and repeating decimals. I am telling you, these details are related to 9th class basically, but I am telling you here also so that you can understand the basic concept for the further classes also. Right? Why I am using this terminating and repeating decimals? Terminating means when the divides completed. Whenever you will divide any value by another value, you will get some exact value, and that is actually getting a ending point. For example, 5 divided by 10, you will get the 0.5. It means after 5 nothing will come. But if you divide 2 divided by 3, so you will get 0.666666. So it means it is a repeating term because 6 is coming again and again. But it is non-terminating term. It is actually not terminating. There is no terminal point. If rational numbers are terminating or repeating decimals, non-terminating but repeating decimals, they are called rational numbers. But in the opposite way, if you are having non-terminating and non-repeating decimals, they are called irrational numbers. And I am sure mostly students will ask, what do you mean by irrational numbers? Definitely you will get it. The numbers which are actually coming in the root form, like for example root 3, root 5, right? These numbers, the numbers which are actually prime numbers, or you can say that the square root of prime numbers, the cube root of generally prime numbers, are called irrational numbers. Now, the next topic which we will study here next heading is standard form. What do you mean by standard form? Because generally student gets a lot of confusion here. Reason is, suppose for example I am having 2 upon 3 and suppose I am saying that it is 5 upon 10. Is it a rational number? Is it a rational number? Actually both are rational numbers. There is no confusion. But the problem is, it is in a lowest form or this one is in lowest form. We have to check it first of all. You can see that 2 and 3 are co-prime. There is nothing common, no HCF except 1. It means this is actually the lowest form. It means it is a rational number, and we can say that it is a standard form of a rational number. But in the same way, if you see 5 and 10, 5 and 10 are having a common factor. It means we can divide it by 5, we can divide it by 5, and finally we will get it 1 upon 2. So we can say that 5 upon 10 and 1 upon 2 both are rational numbers, but 1 upon 2 is the standard form. 5 upon 10 is not the standard form. If suppose any question is asked in the exams, like convert or find the standard form of 5 upon 10, so you should always convert into the lowest form. Right? So this is actually the standard form. Now I have given the example here also. Minus 3 upon 9, and you can see that after simplify it, we can write it 1 upon 3. And the next one is minus 2 upon 8. We can divide both numerator and denominators by 2. We will get 1 upon minus 4. But the problem again raises here. Minus, one important point which I have written here, denominator should be positive. And here you can see that denominator is negative. So it means this minus we will shift upward. And this is the actual form of standard. Right? So minus should not be in denominator also. Right? Now next heading is absolute value of rational number. What do you mean by absolute value? Absolute value of a rational number is the numerical value of rational number. Why we are saying numerical? Because numerical, it means we actually will not consider the sign. We will not see plus or minus, nothing. No sign we will consider, regardless of its sign. For example, suppose I am having -3 and we are seeing this particular, this is the symbol of absolute value which I have presented here. -3, mod or absolute value of -3 will be 3 because we will not consider sign. Absolute value of -5, -5 and it will be +5 and we will get added and we will get 8. Right? And for example, suppose you are having -5. So what you will get the value here? Actually, you can see this minus is actually outside of the absolute value and this minus is inside the absolute value. So it means the sign which is actually inside the absolute value, it will not consider, but this minus sign will be considered. So we will write it minus and inside sign will be not considered. We will take it plus, or as it is you can leave it. So the final value we will take it -5. Right. Now students, next what we will do next, that is the properties of rational numbers, which is actually the main part of this chapter. Then you can see I have written here properties of rational number. Under addition, subtraction, multiplication and division, it means we will check how the rational number behaves with all operations, what we are actually getting if we apply some properties. So first of all we will take addition. In addition number, first property, very first, closure property. Closure property says, if suppose you are taking addition operation, so if you are checking a plus b, means if you are adding, because addition operation is here, if you are adding two of any rational numbers, the result should be a rational number. Are you getting this particular result or not? You have to check. With the help of example, you can see, suppose you are having 1/2 and plus 1/3, so you will get 5/6. Now you have to see the result which you are getting on right hand side. It is a rational number or not? Definitely it is a rational number. So we can say that closure properties holds good for rational number under the addition operation. So closure property holds good. Now next property is commutative property. So what do you mean by commutative? Commutative property says, if I have two rational numbers a and b, if I am adding, and if I change the order, it means b will come on the first position and a is on the second position. So what is the change? Are you getting any change, or we have the same value? Definitely if you see, you will have put any example here, 1/2 plus 1/3, I am taking the previous one. So you will get 1/5/6, sorry. And on the right hand side, suppose you are saying I am taking 1/3 first and 1/2 here. Again I will get 5/6. So it means, again we can say that commutative property holds good. Right. Now next property is associative property. What do you mean by associative? Associative, again, in associative we will take three values, three rational numbers. Suppose I am taking a, then b and then c. And which operation we are using here? Addition operation, so we will put here addition. But associative properties say, suppose you are taking two rational numbers in one group, and this bracket is actually saying we have to solve this bracket first. Then what value you are getting, you will check. If I am saying no, I will not take B and C together, we will take A and B together. Now what will be the result? If we are getting the result same for both conditions, then we can say that associative properties holds good. Again we will put any example here. Suppose you are having 3 upon 4, then 2 upon 4 and 5 upon 4. You can take any one. So I am taking left hand side here so that you can understand it clearly. 3 upon 4 and this one I think 7 upon 4 you will get it, and at last you will get 10 by 4. And in the same way, if we take right hand side, again we will put 3 upon 4 in place of A and 2 upon 4 in place of B and this 5 upon 4. Now we will take these two rational numbers together. So it will be 5 upon 4 and this 5 upon 4 is outside of the bracket. Now again we will check it. Again, you can see that 10 upon 4 is coming. It means left hand side is equal to right hand side. And at last what we will write here? Associative properties holds good for addition operation for rational number. You can see. Now the next which is very important is identity. Identity, and we will check the inverse. I think we have done in 7th class also, but here we are applying in rational number. So the next one is identity. We can say that additive identity because we are actually working for addition operation. What do you mean by how can we get identity here? So students, suppose I am taking any rational number A and the identity say, suppose I am adding any number here and I will get the same number again. So what should be added here? What should be added in this rational number so that the result will be unchanged? Definitely it is 0. No doubt. Or if that number is added with the rational number, in the commutative property also we have to check in this way. Now you can see, suppose 1 upon 2 I am taking. If I add 1 upon 2 with 0, definitely I will get 1 upon 2. And if I just apply the commutative property here, also I will get 1 upon 2. It means 0 is not affecting the rational number, value of rational number. So we can finally we can say that 0 is additive identity. Right? Now inverse. What do you mean by inverse? It is just opposite actually. Why it is opposite? Suppose I am saying that A and then plus B. What do you mean by A and B? Both are rational numbers, definitely. A is one rational number, B is the second rational number. And we are getting 0. It means on what is 0? Identity. If by adding two rational numbers we are getting 0. We are getting 0. By adding two rational numbers, if we are getting 0. then we can say that these two numbers are inverse of each other. These two numbers are inverse of each other. I am repeating again. What do you mean by inverse? If we are adding two rational numbers and we are getting identity, and what identity we have taken here? 0. 0 we have proved. Then we can say that these two rational numbers are inverse of each other. For example, suppose 4 upon 5 I am taking. So what should be added with 4 upon 5 so that you can get 0? So you will say that minus 4 upon 5. Right? So we can say that minus 4 upon 5 is the inverse, additive inverse of 4 upon 5. Minus 4 upon 5 is the additive inverse of 4 upon 5. In a simple way, we can say that if suppose anybody is asking you, okay, what is the additive inverse of 1 upon 2? So you can directly write minus 1 upon 2. Change the sign. What is the additive inverse of minus 3 plus 3? What is the additive inverse of minus 3 upon 5 plus 3 upon 5?